All right, seventh graders. Welcome to the class notes for moon phases, eclipses, and tides. This video is going to take you just through the moon phase part. You will find the corresponding document to help you and to take notes as we go through this. And the document is found in Google Classroom called Class Notes Moon or maybe Lunar Phases, Eclipses, and Tides. The way I have that document set up is that I put just the titles that go with the headings for each of my slides. Your responsibility then is to type in all of the bullets that are on that slide. So unlike a regular guided notes where maybe I'm having you just fill in blanks on parts, this is more like kind of when I give you guys, I want you to do the whole notes yourself. And sometimes I give you options of doing it on paper or doing it on a doc. I gave you the doc and I formatted it at least with the headings from each of my slides, the titles for each of my slides as subheadings for you, and you're going to put in the bullets then underneath. And you'll see as we go through, there'll be some slides that I don't have it recorded on your doc because I'm not requiring you to write notes for that slide. So it's not every single slide. So we'll go through those, and I'll make that clear as we go through it. I'll do my best to go slowly and to put in pauses in there. But if ever you need to, just hit the pause button. Stop me. Type in what's up on the screen so that you're staying up and you're staying up to not only to date with the notes, but you're also being able to listen to me because that's kind of the whole reason why I'm making these videos so that you can hear just like we'd be doing a notes day. Okay, so. Buckle in. This video is a little bit long, but this is the only thing for the week for the notes, and it's all about moon phases, and it's really not that much of notes as we go through this, and so it shouldn't be too hard. Plus, moon phases is something that you guys just had back in 5th grade, so my guess is that a lot of this is just refresher and review. That a lot of it is not brand new material for you. It's just kind of refreshing it for you. All right, so let's go ahead and go to the PowerPoint here. Make sure you have that doc open if you want to do split screen or however you want to do it. Get yourself set up and then go ahead and hit play and let's go through the notes. All right, here we go. So let's start off. Nothing for you to write in here. Go ahead, hit the pause button, read through these 5 statements on the moon, and in your mind, figure out who is correct, because only one of these statements is correct. So go ahead, hit the pause button, read through those now. All right, so as you went through these, some of these are a little bit crazy and are silly. Some of them are actually things that I've heard people say, sometimes even adults say, for the reasons why we see different phases of the moon and the way the moon is illuminated. Okay, and so hopefully as you went through this, you were able to determine that it was Eric that is correct, and that's the other things aren't necessarily 100% correct as we go through them. And like I said, some a little bit more silly than others. But Eric said, from Earth we see different amounts of reflected light depending on where the moon is in its orbit around the Earth, and that is the correct reason for the phases of the moon. And for this unit, it's important to be able to recognize the phases when you see a picture of the moon, to know the order of those phases, to understand why we only see one side of the moon. And then later on, we're going to go through and talk about how the moon affects tides, and then being able to understand the placement of the moon for eclipses as well. Okay, so we're going to start pretty basic though with some facts about the moon, and then why we see certain phases. So let's start with the difference between rotation and revolution. So on your notes, you'll see a heading for rotation. I would like you to put in what you see up here on the screen. Okay, go ahead and pause and type those in now. So the spinning motion of a planet or celestial object on its own axis is rotation. Okay, and so the Earth rotates about 24 hours. And so that's a day. Okay, so it's rotating. So imagine me taking a basketball and spinning it on my finger. That would be rotation. Compare that to revolution. Revolution is when the object is moving around another celestial object, And we have a revolution of about 365 days around the sun. Go ahead, pause, and type that into your doc. So, using that example of the basketball, now what I would do, and I'm going to pretend, since you can't really see me, I'm going to pretend like I can do this and I wouldn't fall down or the ball wouldn't fall, but let's pretend I would spin the basketball on my finger as I walked around my desk at the front of my room. So the ball is rotating on my finger, and then it's also revolving around the desk. And that's what the sun's doing. I'm sorry, that's what the Earth is doing around the sun. Okay, it's rotating in place. That gives us our days every 24 hours, and then it slowly revolves around the sun for an entire calendar year, which is about 365. It's a little bit more than that, which is why we have leap years, but we're not going to get into that right now. So how does the moon then travel through space? Well, the moon also rotates on its axis, which is one misconception that people have. People don't think that the moon rotates. That is incorrect. The moon sure does. It rotates. Its rotation period is about 27.3 days. It also revolves around the Earth. So it spins on its own axis and it revolves around the Earth. And notice this. The period of revolution that it takes is the same, 27.3 days. Interesting. Well, that creates synchronous rotation. And what synchronous rotation is that when the period of rotation equals the period of revolution. And when that happens, always the same side of the moon is facing the Earth. Okay, pause the video, type in all these notes, and I'll explain that a little bit more. So, synchronous rotation. So if you want to sound smarter on your dinner table today, go through and explain this to everyone else sitting at your dinner table today. That the rotation and the revolution is the exact same speed. And so what that does is that means the same side is always facing us. If it didn't rotate, we actually would see all sides of the moon. So when people say, well, the moon doesn't rotate, that's why we're able to see only one side. That's actually completely inaccurate, because if it didn't rotate, we actually would see all the sides. Okay? And I'm going to go through, and I have a video here to show you that's going to kind of demonstrate a little bit better, because, again, I'm not in front of you in front of my classroom. I could do this demonstration for you that makes it pretty easy to understand. So we'll get to that with a video here in a moment. So there's the side facing the Earth that we're used to seeing on the left. On the right is the dark side of the moon, the side that we don't see. If you're wondering how that picture is even there, it's because there are different satellites and probes and things that have gone up around the moon to take pictures, the Hubble telescope, all these things. Nothing to type on this slide. Okay, so I decided to break this into two different parts. So if you're working on this on Monday, I think this is a good place to stop, so that to break it up and then come back and do part 2 tomorrow on Tuesday, so that it's not too much for you to do. If you want to keep going, you can. It was just easier for me to make this too by putting it into 2 shorter clip videos than having one really, really long video. It makes it hard to kind of upload and stuff. So part 2 is on another video. It's also on Classroom. All right, thanks.